Welcome to the DIY Honda Garage channel. The DTC P2195 indicates that the air-fuel AF sensor, specifically sensor 1, is reporting a signal that is stuck lean. This means that the sensor is continuously indicating a lower than expected air-fuel mixture to the powertrain control module, PCM. This can lead to various engine performance issues such as reduced fuel efficiency and increased emissions. The AF sensor plays a crucial role in maintaining the correct fuel-to-air ratio, which is essential for optimal combustion. Its location is typically within the exhaust system, just upstream of the catalytic converter. This strategic placement allows it to accurately measure the air-fuel ratio before entering the catalytic converter, ensuring that the engine runs efficiently. The air-fuel sensor, often referred to as the A-fuel sensor, is responsible for monitoring the air-fuel mixture entering the engine and helps the PCM make necessary adjustments for optimal combustion. It does this by sensing the concentration of oxygen in the exhaust gases. If the sensor indicates a lean condition, meaning there is too much air compared to fuel, it results in inefficient fuel combustion and can lead to performance and emission issues. The A-fuel sensor, sensor 1, is typically located in the exhaust pipe, usually after the exhaust manifold and before the catalytic converter. This placement allows for accurate monitoring of the exhaust gases, and any faults or signal discrepancies can lead to DTC P2195 being triggered, meaning troubleshooting and verification steps are necessary. Several factors can lead to the DTC P2195 being triggered. Firstly, a dirty mass airflow MAF sensor or intake air temperature IAT sensor could impede airflow readings, causing the AF sensor to report an inaccurate lean condition. Secondly, a faulty installation of the AF sensor could lead to miscommunication between the sensor and the PCM, impacting overall performance. Poor electrical connections or loose terminals at the AF sensor or the PCM may also contribute to unreliable signals being sent, verifying the need for an inspection of wiring and connections. Each of these components plays a significant role in the accurate delivery of fuel and air mixture, and any faults in these areas could result in engine inefficiency or increased emissions. When experiencing DTC P2195, several symptoms may manifest. A key symptom is reduced fuel efficiency, as the engine consumes more fuel in an attempt to compensate for the perceived lean condition. Another significant indication is increased emissions, which could potentially lead to failing emissions testing. Additionally, the engine may experience stalling or hesitation during operation, particularly during acceleration. Drivers might notice a lack of power or performance that may affect safe driving. Overall, these symptoms not only affect the vehicle's drivability, but also indicate underlying problems with engine performance that must be addressed through thorough troubleshooting. In the first step of troubleshooting DTC P2195, the mass airflow sensor and intake air temperature IAT sensor must be inspected visually. These sensors are crucial as they provide the PCM with essential data regarding incoming air. If there is dirt or debris lodged in these sensors, it can hinder their performance, causing inaccurate readings that contribute to a lean condition in the AF sensor. Should you find the sensors to be dirty or obstructed, it is important to clean them thoroughly to restore proper function. In cases where the sensor cannot be cleaned effectively, replacement might be necessary to ensure accurate airflow measurement. After addressing the condition of these sensors, repair verification steps should be conducted to confirm the results. The second troubleshooting step involves examining the installation of the AF sensor, sensor 1. It is essential to confirm that the sensor is not loose or incorrectly installed in the exhaust pipe. An improper installation can lead to erroneous readings being sent to the PCM, which may trigger DTC P2195. A careful inspection of the sensor's mounting should be conducted to ensure it is secure and properly seated. If any looseness is found, reinstall the AF sensor firmly to prevent any random signal losses. Once this has been done, it is crucial to proceed with the repair verification process to assess the effectiveness of this corrective action. Step 3 requires turning the ignition switch to the on position, specifically to position 2. This action powers the vehicle's electronic systems, enabling you to access diagnostic functions with the Honda Diagnostic System, HDS. Clear the existing DTC from the PCM using the HDS, which resets the internal error codes and allows for a fresh diagnostic read. After clearing the code, start the engine and allow it to idle without load until the radiator fan activates. This condition is vital for accurately assessing any pending or confirmed DTCs present. By checking these DTCs post-clearance, you can determine if DTC P2195 persists or if any new codes emerge, thus guiding further troubleshooting actions based on this diagnostic feedback. To finalize the repair process for DTC P2195, it is necessary to verify the completed repairs to ensure the vehicle's systems operate as expected. Start by turning the ignition switch to the on position. 2. To power up the control systems. Next, reset the PCM with the HDS, which clears any history of fault codes, allowing for an accurate assessment of the vehicle's status. Following this reset, conduct the PCM idle learn procedure, which helps the PCM recalibrate its settings based on the new input it receives. After completing these steps, start the engine again and allow it to idle until the radiator fan comes on. Then actively monitor the OBD status through the HDS. Ensuring that the DTC P2195 reflects as passed in the diagnostic system ensures a successful resolution of the issue. Although not explicitly mentioned in the diagnostic text, preventive maintenance is crucial in avoiding future occurrences of DTC P2195. Regular inspections of the sensors, including the mass airflow, MAF, and intake air temperature, IAT sensors, are essential for maintaining operational efficiency. Routine cleaning of these sensors can prevent dirt buildup that may lead to inaccurate readings and performance failures. Additionally, frequently checking the quality of electrical connections associated with the AF sensor and the PCM can help to ensure that signals are correctly transmitted without interruption. Proactive measures in these areas can greatly enhance vehicle reliability and reduce the chances of experiencing lean condition error codes. In summary, the DTC P2195 represents a significant issue related to the air-fuel sensor, Sensor 1, reading a signal that is stuck lean, leading to potential engine and emission problems. It's vital to follow a systematic troubleshooting approach, which includes detailed inspections of critical components like the MAF and IAT sensors, as well as confirming proper installation of the AF sensor. The sequence of steps, visual checks, clearances, problem verification, and final repair validations ensures that repairs are effective. Furthermore, embracing preventive maintenance practices helps in mitigating the risk of encountering this DTC in the future. By combining effective troubleshooting with routine checks, vehicle owners can maintain optimal engine performance and reliability. Please like and subscribe to the channel. See you next time.